Yeah, so the other behavioral pattern, right? So as I told you that I'm reading this book, right? So I'm getting all these ideas and examples from the book, and probably I change it to something that we can easily understand because the book's examples, use a lot of gaming concepts, So I'm not familiar with certain games and things like that, So I just put it to something I understand, and then that's how I'm explaining these examples, right? And honestly speaking, I'm getting much confident with the use of lambdas, right? And then as we saw the chain of responsibility the other day, this one, we wrote lambdas actually to solve problems, right? So I could simply define a lambda like this as a value, like a variable in a file, and then I can use it. So, you know, like because they are also functions, right? Anonymous functions, right? So we can define them to a value too. So if it's a lambda, we can assign that, or a function can be assigned to a value as well, isn't it? So it was quite cool to see all of that. And then today, the next example is the interpreter pattern. Yeah, that is also quite nice as I was reading the book. So this is called interpreter. Do we know what is an interpreter? What comes to our mind, when we say interpreter? Jared, Nila?
Uh,
No, no idea. Maybe
Yeah.
like an interface.
Yes. Yeah. Interpreters, right? I mean, like our
something to
but
explain something. You
yeah, something changes, right? Something converts something to something, no? Interprets.
yeah
Like
yeah that's
yeah, like we have interpreters, like interpret languages, no? Like in real life, isn't it? Like when you go to code, and if you don't understand languages, we can go with an interpreter, right? So, and also the compiler is also an interpreter, no? It interprets the language to machine language, and the machine can compile the code and all that, all that. So we have a compiler. So why do we then need this interpreter design pattern itself? So the compiler, I think, they might be probably using some sort of an interpreter pattern. But this interpreter design pattern itself is telling, if you want to write your own language, like a programming language, set of commands to run, that's when we need to use the interpreter design pattern, right? That's what I understood as. And I could see, it's making sense. For an example, right? So we have XML layouts in Android development, right, Nila? We use XML layouts, isn't it, in Android? So those XML, when you write the XML, that's in its own DSL, right, which is the domain specific language. So in Kotlin,
Yeah.
we have XML layouts, which are tailored to put up a layout, but it's not. It's even though it's XML it's using, but it has its own grammar, right? So we can understand it like that, isn't it? So we know what the attributes are, how to use a view inside the XML. It has its own grammar and format, right? So that itself is a DSL, which is a domain specific language. So if you use a language, or if you design a language to work in a specific language in its domain, then they are calling it as a domain specific language, right? So this DSL. So in order for you to create DSLs, we need to follow some sort of an interpreter pattern, so the interpreter pattern will allow us to, make it working in that domain language, this specific DSL we are designing. So that's what this interpreter design pattern is talking about, So it's saying, you will write your own kind of a DSL, for a language. So that's when we say this is an interpreter pattern we are using. So we rarely do this in any development, right? Because we use the language features. We don't tend to write another language inside a language for any purposes. But those kind of DSLs are written and provided for us, right? So if you think of it like, where do we use a DSL, a domain specific language in a language? XML layouts is one of the examples. So they have applied interpreter pattern there because of it interprets into certain formats, so that we can use it to inflate views and things like that. And also SQL, is another interpreter language which is a DSL, because if I can use SQL statements in Kotlin, right, to access room database and all that. That's where we're going, you know. So, or Gradle, you know, for the building the Android applications, right? So it's used. If you look at Gradle, it's in its own format, right? So we're using Gradle to build the Android application, and its configuration files are written so that the interpreter, I'm talking about the actual interpreter now, the actual interpreter will know how to interpret this. But to put up a DSL, we need to follow the interpreter pattern, because I mean we need to tell how to interpret this so that our language will work, you know. So that's what we're talking about when it comes to interpreter design pattern. So I saw the example, and in the example they're talking about how to write our own language, right? So for instance, right, so imagine any questions so far? Have you guys understood what I was saying? Yeah.
Yeah.
Cool. Right. So today, I mean, so in that example, right, the example they're talking about in the book is showing how to write our own language. When we say, you know, we are going to write our own language, that could become a tedious task, right? Because we are kind of inventing how to put up a new programming language by ourselves, right? It's not that easy. But here, you know, they're just showing that they're just showing, and I mean, how we can you know, how it should look like. And I mean, when we do something like that, that's where we are getting to, right? But of course, using Kotlin lambdas a lot, you know, because Kotlin is so powerful because it has the, you know, functional concepts, right? So it has lambdas to work with as well. So with this great power, we can write the DSL, you know. And when we're doing that, we're actually following the interpreter design pattern. So to tell it in other words, how do we interpret an interpreter design pattern? I would say, you know, when I create my own DSL to work with something in a domain language, then I am actually following a design pattern, which is this, in this case, the interpreter, you know. And then in this example, right? So they're saying, like, I mean, okay, so how do we come up with our own, how do we write a language like this, right? So say, for an example, I want to write my own SQL statement, right? There is no such language like this, but I want to write my own SQL statement, right? So I want to say select, you know, from some columns, like, sorry, we're going to develop this, but let's see, how would this look, you know, my statement. So select name and age, yeah, and I'm going to say from which table, yeah, and then and say where some condition, right? Age is greater than 20 or something, right? So this is how I want to write my SQL, right? So we are going to write classes so that these statements will run using Kotlin, of course, and lambdas, right? So if we make this to work, then we have actually written a DSL, which is the interpreter pattern, right? We are applying here. So we are writing our own language, in this case, an SQL statement, and we are using the lambdas power, you know, to make this working, and also because of that is what is called the interpreter pattern, right? Yeah. Any guess, like, I mean, how we can start doing this? But any questions so far, guys? I mean, have you understood, like, I mean, what's going on? So we can, you know, because of, you know, when we apply a design pattern, this interpreter pattern here, we are writing our own language, right? A DSL here, which is a domain specific language, you know. So this is our DSL, you know, which in this case we're writing up how we're seeing how to put up a SQL statement by ourselves, you know. Yeah. So if I now print this, this should be printing. If I print the SQL statement, I want to see it prints select name, age from users where age is greater than 20. Yeah, this is what we want to see. So the actual implementation, we can go ahead and implement this to do the actual way of projecting the table and pulling stuff out, but we're not going to go into those internals, right? We want to at least see we get a printout, you know? So if I run this, I want to get this gets printed, you know, that's our implementation. That's what we're doing, because I mean, we can't go so much into, you know, write our own grammar for this language and all that. At least how to put this up as a statement, and we just print it. So the implementation itself is just printing it. Yeah, understand it?
Yeah.
Yeah.
Yeah, Thiru.
Yeah, that's the closest we can get to, right? But whereas, I mean, we can go in and, I mean, write things for the select to select things from given columns from a table, uses and all that, but that's too much implementation. We can't do that. I'm not saying, you know, I mean, we can't do it. We can do it, but that's time consuming, right? That's a lot of work. But this is just to see, I mean, how to, you know, put this as an example to see how do we write our own DSL in this case, which is because of, you know, to illustrate, you know, I mean, you know, this interpreter design pattern, right? Yeah, happy with this? I mean, if we can see the print at least, you know, if we have a statement like this. Yeah. Happy, right?
Yeah, Thiru. Yeah, go ahead. We'll see.
Okay. Any guess? Shall we now do this? I mean, where would we start? How can we start this?
No.
Okay, yeah. It took me a while to understand this too, right? I have read the book and then I tried it by myself, and it took me a while because of here. What we need to do is, I'll tell you, because, you know, I mean, I know that it's quite hard, you know, we can't just jump straight in, you know, because we have to think a lot. This will take ages, you know, I mean, hours worth of, you know, thinking needs to go here, right? But I'll tell you, like, I mean, what's the trick here? So if we want to write our own language like this, a statement like this, so that, you know, if we have a statement and we print it, we get a printout like that. We have to look at it like, I mean, how this is looking, right? So here we can think of this as a function, right? So if you have a function, we can give a string in, yeah. And also, see this? That looks like a lambda to me, no? Because of the curly brackets, right? Yeah, because we know how to define a lambda, right? So we know a lambda will be like this. Yeah, I have just declared a lambda. Yeah.
Yeah.
Yeah. No, sorry, defined it. I've defined it, but declaration is the type declaration. So I can say this doesn't take in anything, and also doesn't return anything. Yeah. So we have just declared it and defined it as it's empty, right? This is a lambda declaration, right? So, but what is this? Because it's in the curly brackets, right? So it's a lambda. Yeah.
Yeah.
And here I can see a lambda here, right? And do you guys know that, you know, if a function, say that, I mean, we have a function, let's say a function, test or something, and then we say it takes an input as an integer and a lambda, right? Say lambda, sorry, lambda, which doesn't, yeah, it's an empty again, yeah. So if we have a test function like that, let's comment this out. Now, this is our goal. We'll come to that, but we have to brush up a little bit concepts here. So if I have something like this, and if I need to call my test function, I can call it as this, right? Yeah. Yeah, because I'm passing lambda to satisfy, you know, what which is actually this is. We can name the parameters too in Kotlin, right? This is my x, no? Yeah, we're happy with this now. Right. But because of the last one, if the last one is a lambda in Kotlin, you can do this as well, no? You can suffix it. Yeah. So now this is your lambda. Because, you know, if the last parameter in the function is a lambda, we can call suffix it. This is called calling call suffixing it, right? Have you come across this, Nila?
Yeah, yes, Thiru. Yeah,
Remember
like
this, right?
like yesterday, I think.
Ah,
But
yeah.
I didn't
Ah.
know what this concept, but it suggested that
These are
it
some
suggested,
magic.
so
I
I
know.
went to
Yeah,
it that.
I
That's it.
know. Yeah, but these are some
Thanks
rules.
for that.
Yeah, these are the things, I mean, me too. But because, I mean, until we see this and, talk about this, it stays as some magic. But this is the Kotlin rule. They made it as I mean, they have written their Kotlin grammar to be like this. So if you ever have lambda as the last parameter in your function, you can call suffix it. This is what it's called, call suffix. They have a name even for that. Call suffix. So we can
Call
find it in,
suffix.
yeah,
Yeah.
in the
I
review.
used unclick listeners for the lambda.
Yeah.
So at the time, it suggested we don't need these curly braces like
Mm.
that,
Yeah,
comma,
yeah,
like
yeah.
that. It suggested. So I just
Correct.
go.
Correct. Even the ID will suggest, I think, in this case, move lambda argument of outer there you go. That's it. Yeah, that's what we did. Move it out because of its call suffix. Yeah. Right. Okay. So now let's get an idea from this. So we also have, you see, this is a function and we are call suffixing it. It's going out. So if we have a select function, we can have a string as the first parameter, and then we can have a lambda, like in this case here, right? Yeah. So this will pretty much select function, right? Select function should have so name and age. If you say the name and age are the columns we are picking in our SQL grammar. So we can say this is a string, but then let's name this as column, yeah, and then a lambda, right? That's what this is going to be, because now I'm seeing this backwards. I mean, I'm seeing what this is doing, and then I'm trying to put up a function for it. So I can see this is like, calling a test function like we had. So the first input is a string, and then the second input I'm seeing that as because this is in curly brackets, I am putting this in a lambda. I'm defining it, that's my lambda, which we can say, which this can be the from, yeah, which is what the lambda is coming in to put in, right? Yeah, okay, right. So far, quite okay. So let's now see, we can now open this guy and see how much is okay. See, now the select function is all right? You see, because I'm passing a string for the column, and this from is a lambda, yeah, but it's an empty lambda at the moment. But we, of course, now need to write a class for the select, because of something needs to, the lambda here should give him something to work the from bit, So then what I did was I did this select close as a class, and then I said this will this will give me the names, because the ideal goal is to print. So I'm going to pass in stuff so that, we can print it. So here, don't worry too much of, how I'm solving this, because I took so much time, I took about 2-3 hours to solve this by myself, without looking at anything. There is a solution in the book as well. So I didn't go straight into the solution. So I was trying it out by myself, like how I can, solve this using Kotlin with how much I know, So it took me so much time, and then I understood something, and I studied something, and I learned something. That's which is important, right? So if we learn something out of this, that's what we want to keep it as, so that then we can remember these things, so which we can use in the actual code later, in production code or at work, we can apply this, no? So that's why I'm seeing this. So don't worry too much, because I'm skipping all the 2 hours of me solving this now, so that you can imagine like you've solved it too. That's what I'm saying, right? So don't worry about it, spending all that time. So I'm just showing you how I solved it, and then we can learn something out of this as well, like the usage of lambda, because that tricked me a lot. And then I've learned something new too with the lambdas, right? Okay, anyway, so here I need the column name, yeah, to print, because I need to print this, whatever we put into this, we need to print it, because that's our ideal goal, because this is our implementation, no? This is how we want to say our implementation is working, because if we see this line printed, then our implementation is working, right? Right, so let's get the column name here, whatever the things we pass in, which is a string, of course. Yeah. Yeah, string, private val. Yeah, right. So the select clause I'm writing. So this is how I'm gonna see it as, I mean, this has a function, but it needs to give me the select clause to work with, you know, so that I can print this, you know, select no, sorry, what I'm doing. Yeah, it needs to give me the select clause. So now I can say I need to return a select clause, right? Which takes the column. So I'm passing it in so that I can print it here, because if it's in a class, I can read this and print it, but at the same time, I will need to work this bit, you know, now. So the select function is there now, which is this. We have put up a select function to pass in a column name, which is this. And also we are saying, okay, I will be passing a lambda, which is this. But then how do we go inside and work with it? That's when we need a class itself. So it takes the column name and it needs to call this, right? So we are inside the lambda here. Yeah, which is actually, yes, it needs to give you a class to do this, right? So what I'm going to do is I'm going to make this as an extension function. You see this? The extension function. So that gives me the select clause here so that I can get it here, right? Which is this, and I can call the from, which can now come as a function in this class, no? So see the way I'm kind of connecting the dots. Now this is okay. I can omit this too, because, you know, I mean, this is just calling that function. You see, I'm calling this function here now. Yeah. So see, I am kind of filling in every place I can get this to working. All that, see, all that red scribbles are going away now, you know. So I'm working backwards. Like I'm seeing this statement as, I mean, what are the things I need to put up this. Normally we will write our class and the functions we need, and then we'll finish it with, I mean, how this will be used. But in this case, we're working backwards. We're seeing what is the output results and then trying to put stuff we need for it, you know, by filling in the things, you know, so that these will start working, start looking correct, you know. That's what I'm trying to say. Yeah. So see, so the moment, okay, but then the takeaway here is this guy. This is a lambda extension. It's not just a lambda like this, you know. Normal lambda will be looking like that, but this is a lambda extension. You guys know extension functions, right, in Kotlin?
Yeah.
Yes. What is an extension function? Charit, you know this too, no?
Yeah.
So say, for an example, if I now say string dot my function on string, this I'm extending some features on string, right? So I have written a function called test, which I can call on anything, any string object, right? This is our extension function. So if you have an extension function like that, you can have an extension lambda too. So here, this means if I have a select clause, I can apply this function on a select clause, because if I have a class, and that's the function I can apply on. If I have a class string, this is the function I want to extend on, which is exactly the same, but it's in a lambda, you know. So what we can then do is, so here I have this object, which is this, right? The select clause, and I can apply this because it's an extension function. Sorry, it's an extension lambda, which is this, but the receiver is this. So this is how we read this. So if it's an if somebody says, or if we see extension lambda, what we see is the lambda part is here, but the receiver is important. The receiver is the object which is we are extending the, you know, lambda on. So the receiver will be that object. So here we have that object. So I can apply that function on it. Oh, apply the lambda on it. This is the lambda. See, that's why it's not, you know, it is the lambda. So this is my lambda. You see, that's my lambda. That's not really a normal function. That's my lambda function. you know, I could apply that on this, which is this. Do you know this apply? What is this apply? Do we know this? In Kotlin, you have these receiver functions, right? Apply, let, this and that. You know, we have other things like let,
Yeah.
run, with, apply as well. Also, you know, these are there, no?
Yeah.
Yeah. So I'm using this receiver function, which is apply. Or if you don't want to do that, you have to do this. You have to call this. So sorry. No, you can't, because you know we have to return this object to
Something. Yeah.
Yeah, that's why I can't apply. If you're not returning anything, you know, let's say, you know, this doesn't return anything, then I can call that lambda on it. See, this is invoking the lambda on this because of it's an extension lambda, right? Which is this. Yeah. No, that's wrong. So I can maybe let's say this is a different one. And then I want to call this lambda. Yeah, now I'm actually calling this extension lambda on this because of this extension lambda's receiver is this object. So if I have an object of select close, I can apply this. I can call my lambda on it, invoke the lambda on it. You know, that's exactly like calling an extension function on an object, right? So I can do that. But at the same time, you know, what we had was we had to return this guy. So that's why I'm using an apply there. You know, so I need to return the object. So I can return this object. When it's getting returned, I'm applying it. So the apply wouldn't change this object. This will get returned, and at the same time we apply something on it. You know, the lambda extension on it. You know, so we just call the extension function on this. Sorry, the lambda extension on it, like invoking a lambda on it, and at the same time we return this. So it looks quite cool, no? So we can do two things at the same time. We can apply a lambda on this guy because of why we can apply a lambda on this, because of it's an extension lambda on this object. This is the receiver. So if I have an object similar, which I have the same object, select close, I can apply this, right? At the same time, this is getting returned. Yeah. So now, so far so good, because this select function has this, and that's what we are returning here. So no, sorry, this is the lambda, which is this bit here. The receiver is select close because we made this as a lambda extension. So this comes in, and when it comes in, that's my receiver, which is this object. If I have that object, I can call the method on it, which is this function here, right? And I'm so far so good. Now we're going to repeat the same for these, the rest of them, to go inside. See, now if you look at this, let's put these back as from, because of it's calling that method. Yeah, so it's calling this method here. Now let's see this from. Now looking at function. So I'm kind of doing the same thing now inside. So I can see this is a function. Yeah, we have a function for that. Yeah. And then see, it takes a string. Yeah, it can. Yeah, it takes a string. So we can make this as a string, which is our table name or something, no? Table name, which is a string. And then you see now same thing, same technique. This is a lambda. It's taking a lambda. So we can say this takes lambda, which would be the where, you know, this would be our where clause, isn't it? Yeah. So now the same thing I'm doing. So it's exactly like we've solved the other bit. So yeah, I need no, actually this is the from clause. No, this is the same as this what we did. So yes, from no, where we need, but this will be from close extension lambda. I will just apply that, same. I'm just following the same kind of principle here, technique here, so that I can come into this bit, with this close, so that I can call where on it, so that will be a function on it on another class or something. You see, the same thing I'm doing. So now I need a class for from close, yeah, which can bring in with something, but then I'm going to have a function called where. So see, now this where is good. I'm calling that because I'm passing it an extension lambda here, which is the from close coming in, and I'm receiving that from close by passing this lambda here, I can call the function where on it, right? Any questions? Any what do you think, guys, so far? Can you see the way this is getting filled in and starting to work?
Yeah.
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 And yeah,
I can understand.
yeah. Did you understand the extension lambdas? Have you used extension lambdas? Nila?
I don't think so.
Okay. Right, I'll show you. It's similar.
Maybe I'll check after
Mm.
this
Yeah.
session. Maybe I'll check if I work on that. I can identify whether I
Yeah. Sure. No problem. Yeah. So this is what I've understood after this, right? We can make this as a normal lambda too. I can change this to take an input as this, right? Then I'll have to say it dot from. See that now it changes because that's the input. So it'll say it. If you have a parameter in a lambda, it will be called as it. So I have to call that to say that's the function. So yeah, if I see this, I can change this to an extension lambda too, because it's exactly the same. Instead of passing this into its input as the first parameter, I can make it as an extension lambda, which in this case, and then we can at least get rid of this it, because that's what that comes as, and I can call straight away the function on it, which is exactly the same. So having a normal lambda and an extension lambda, they are both the same, but the readability would be a bit more cleaner here, I would say. Other than that, they're both doing the same thing, a normal function and extend function, they're both the same, kind of, what I mean? But the way we call them will differ from, if it's a normal function, it's taking something, it'll tell, that input parameter will be identified as it. But whereas here, if it's an extension function or lambda, we can, omit saying, what object is coming in as a receiver and call the methods on them. So it's not very different, extension functions and normal functions, or extension lambdas or normal lambdas, they're the same. I'll show you an example, which after I've studied this, I've applied it in the code, we were using to build this application, right? And I've immediately used it, and it looks much readable, using this concept. But anyway, right, so we are now here, right? But this from thing needs to print as well, right? So we have a class, we're calling these functions, but where are we going to have our output as, to print this? So we need to now sort out the printing too. So how are we going to print? So when this function is called, it's actually creating this object, right? This object, and it's giving us the things we need, the name of the column, table name, and where is lambda here. So we can start printing, right? The printing now, what we can do is, because of it's a class, we can override the toString method, no? And we can say, yeah, how do I want to see this now? So I want to print this. Sorry, it's a string, yes. So I can start with saying select, because that's what we want to see when this runs. Yeah, I can see select. Now my, of course,